Good morning. Welcome to Data Talks Live. I'm Dr. Tom. On this show, we dig into the numbers, cut through the spin, and look for the data-driven truth behind the issues that matter. Today, we're tackling three major stories that, on the surface, might seem different, but share a common theme. The infrastructure behind our digital lives is running into real-world limits, trade-offs, and surprises. Here's what we have on today's docket. A backlash against AI and data center buildouts in places like Mexico and Ireland, the global buildout of data centers and the strain on energy, water, and community resources, the traumatic outage of Amazon Web Services that took large swaths of the web offline. Let's dive in. When cloud and AI meets drought and grid limits, backlash in Mexico and Ireland, what happens when the digital cloud actually pulls down the roof from local water wells and electricity supplies? Let's start with two contrasting geographies. First, the central Mexican state, despite drought conditions and water stress, the region has become a magnet for hyperscale data center built by major tech firms. One report notes that data centers are being allowed to skip environmental impact assessments while local water access is already under strain. Second, in Ireland, which for years welcomed huge data center investment thanks to cool climate, tax incentives, and connectivity, the infrastructure boom is now hitting limits. Dozens of massive centers around Dublin reportedly consume about 21% of the nation's electricity in 1 year, prompting grid operators to halt new builds near the capital until 2028. In Ireland, estimates show that data center sector consumed 21% of all electricity, making it one of the highest burdens to Europe. In Mexico, data center players are being exempted from environmental impact review and CO2 taxes, even as the region is water-starved. Experts say that while the promise of jobs and economic growth is often emphasized, what's less visible are local trade-offs: land use, water consumption, strain on power grids, and environmental disclosures. This matters because the digital economy isn't purely virtual. It has physical footprints. We often think of the cloud as intangible, but every AI model, every server farm, every data center is built on real land, uses real water, and real power. For communities, when you attract giant data centers, you gain benefits, investments, and jobs, but you also get the burdens: resource strain, infrastructure stress, and environmental cost. For our listeners, the next time you stream an AI service, upload a file, or train a model, think about where the racks sit, how they're cooled, and how the power arrives, and how the water flows. From these two studies, let's zoom out to the global trend, the data center build-out and how it's structured, and the systematic pressure points being revealed. The global data center build-out hitting ceilings. If you thought the cloud was boundless, you might be wrong. The infrastructure powering it is bumping into limitations. With the explosion of generative AI, streaming, cloud computing, and connectivity, demand for data center capacity is surging, but that means more electricity, more cooling, more land, more water. And increasingly, governments, grids, and communities are saying, hold on. Some of the pressure points: power grid constraints, regions used to attract data centers with cheap land and tax breaks, but now they're finding that the grid can't sustain further expansion without the risk of brownouts. So, providers are often building their own power generation on site. Cooling and water demands. Many modern data centers rely on large amounts of water or sophisticated cooling to keep servers from overheating. In many locations, this is increasingly contested. For example, a single large data center can require millions of liters of water per day. Regulatory and planning pushback. As seen in Ireland, the grid operator paused new data centers until at least 2028 in the Dublin region. The advantages that attracted data center investment, cheap land, favorable utility rates, tax incentives, are being undermined by resource constraints. Companies are now factoring in risk of siting delays, community opposition, local infrastructure limits, and sustainability scrutiny. From the data lens, we need better measurement of resource use, power, water per server, per workload. Many disclosures are opaque or aggregated, making accountability hard. As one report states, up to half of data centers don't measure how much water they use. The Mexican and Irish stories are early signals of what many regions will face as digital infrastructure grows. The local limits are not just environmental, they're infrastructure, regulatory, and social. And if the infrastructure is under strain, when it falters, the consequences can ripple broadly. That leads us to our final segment, a major outage of the cloud giant and what it tells us about the fragility of our digital backbone. Major AWS outage over the weekend and lessons on fragility. What happens when cloud giant sneezes and half the web catches a cold? That's exactly what recently happened with Amazon Web Services. On October 20th, AWS experienced a major outage in its U.S. East region, Northern Virginia. that impacted numerous services and platforms, from gaming apps like Fortnite to productivity tools to messaging services to crypto platforms. In its status update, AWS reported significant error rates for requests to the DynamoDB endpoint in the US East 1 region. This issue also affects other AWS services in the US East 1 region. Because AWS is so foundational and it supports large parts of the internet, the outage affected thousands of apps and services globally. The disruption underscores that even cloud platforms are bound to regions, centers, and physical resources, and when those fail, the ripple spreads. From a risk perspective, this shows centralization risk. If too many services rely on one region or one provider, then system-wide shocks become possible. What is the resilience strategy of cloud users? Are they multi-region, multi-provider, or concentrated? How transparent are cloud providers about outage risks, dependencies, and mitigation? If data centers are under resource stress and they fail, what does that mean for service continuity? This outage was more than a tech glitch. It's a data infrastructure alarm bell, and it reminds us that digital services we rely on are as strong as the physical, network, and energy-bound systems that underpin them. When you pick your cloud region or choose one provider for convenience, ask, what are the geographical risks? What is the fail-safe? And where is the resource bottleneck? Today, we've traced a compelling arc, from local backlash against data centers in Mexico and Ireland, to the global infrastructure ceiling for digital expansion, to a dramatic outage in one of the largest cloud platforms. The underlying theme: data infrastructure has physical, resource, geographical, and resilience limits. As always, I encourage you, don't accept the metaphor of the cloud is endless and unlimited. Ask the hard questions. Who bears the costs of infrastructure, locally and regionally? What are the trade-offs between growth and sustainability? And how resilient is the system you rely on when the backbone bends or breaks? If you enjoyed this episode of Data Talks Live, please subscribe, leave a review, share it with your network, and next time we'll drill into how computing and decentralized infrastructure might reshape this model. I'm Dr. Tom. Thanks for listening or watching. Stay curious, stay skeptical, and speak data.